So we're going to pick up where we left off yesterday. We had started graphing number 3. We had identified the parent function as f of x equals x squared. We made our xy table of the parent function using our points -2, -1, 0, 1, and 2. We identified our HSRV, so now we want to make our new xy table with HSRV. Remember that the h is the only one that affects the x value. It was x plus 1 inside parentheses, so it always comes out opposite. So in our new xy table, it will become x minus 1. Our S, R, and V is what affects the y. The S and the R multiply the y, and then the V is added to it. And so we will have negative 2y plus 1. So now we go back to our original parent function. All of the x values, we will subtract 1. So negative 2 minus 1 gives us negative 3. Negative 1 minus 1, negative 2, 0 minus 1, negative 1, 1 minus 1, 0, 2 minus 1 is 1. Now with all of the y's, we start with the 4, and we do 4 times negative 2 gets us negative 8, plus 1 puts us at negative 7. We go back to the 1. Negative 2 times 1 is negative 2. Negative 2 plus 1, negative 1. Go back to the 0. So we end up with negative 2 times 0, 0. 0 plus 1, 1. Go back to the 1, and we get negative 2 plus 1 is negative 1. And then the 4 is going to give us the negative 7 because they are symmetrical, and we already knew that. So now we want to plot those points. So we will plot negative 3, negative 7. It's going to be a little bit off our graph. Negative 2, negative 1. Negative 1, 1. 0, negative 1. And 1, negative 7. And then draw our parabola. Remember, it is going to be a U shape because it is a parabola. So that finishes up number 3. So now we want to move on to number 4. The original function they give to me is f of x equals negative 1/2 x plus 2. We need to identify the parent function. So negative 1/2 x plus 2, that's just a line. Remember to identify the parent function. You get rid of everything that is with the variable. So our parent function was just f of x equals x, which is just the diagonal line. So we're going to make our xy table. Negative 2, negative 1, 0, 1, and 2 for the parent function. Since the parent function is f of x equals x or y equals x, then my y's are the same as my x's. So now we want to identify HSRV. H, remember, is the horizontal shift. There's nothing in parentheses with the x, so there is no horizontal shift. The S, that is the number that's in front of the variable. So yes, we have an S, and it's by 1/2. The R is the reflection. That's only if we have a negative. Yes, we have a negative, so we have a reflection. The V is the vertical shift. That's what's being added or subtracted. So yes, we're going to go up 2. So now we want to make our new XY table. There was no horizontal shifting, so the x's will all stay the same. So negative 2, negative 1, 0, 1, and 2. The y's, the s and the r get multiplied by y, so we have a negative 1/2 y. And then the v gets added to it, so plus 2. So now we want to take each of our original y's from the parent function and multiply by negative 1/2, and then subtract 2. This is minus 2 up there, or sorry, plus 2. Okay, so now we're going to take negative 1/2 times negative 2, and then add 2 to it. Negative 1/2 times negative 2 is 1. 1 plus 2 gets us 3. Negative 1/2 times negative 1, and then add 2. So negative 1/2 times negative 1 is 1/2, plus 2 is 2.5. Then we take the 0. 0 times negative 1/2 is 0 plus 2, so we're at 2. Then we go back to the 1, so negative 1/2 times 1 plus 2. So we have negative 1/2 plus 2, 1.5. And then finally the last one, negative 1/2 times 2 added to 2. So we get negative 1 plus 2, negative 1. So these are the points that we want to plot. So we go over negative 2, up 3, make a dot. over -1 up 2.5, make a dot. 0 to 2 over 1 up 1.5, and 2, -1. And then connect them. This was just a line. Right, so that is the HSRV of all of those. So now we're going to look at the next page. Here we're looking at where they give us a function, the graph, and they ask us to graph transformations based off of that. We don't know what the original equation is, and that's fine. We can go ahead and, off of the graph that they do give us, look at these points to put in our XY table. So if I make my original XY table, then I see that this first point here is -4, 2. My next point is -2, 4. My next point is -1, 3, 0, 5, and 1, 7. So number one, they want us to graph y equals -f of x plus 2. So we want to first identify h, s, r, and v. Remember that our h, right, that is anything that's inside parentheses. We have x plus 2 inside parentheses. It always goes the opposite. So that is going to go left 2. The s is if we have a number other than 1 being multiplied by the entire function. We do not, so that's nothing. The r is a reflection. That is only if there's a negative out front. Yes, there's a negative. V is vertical, anything being added or subtracted. There is not one. So now we're ready to make our new XY table for that. We had the h was a left 2. The parentheses said x plus 2. It always comes out opposite, so this is going to be an x minus 2. S and r get multiplied by y, so the only thing we have is -y. So our y's would be easy to go ahead and get because we see that our original parent function y's, all we have to do is make them negative. So -2, -4, -3, -5, and -7. We want to take the original x's and subtract 2. So -4 minus 2, we have -6. -2 minus 2, -4. -1 minus 2, -3. 0 minus 2, -2. 1 minus 2, -1. These are the points that we're now going to plot. So -6, -2. -4, -4. -3, -3. -2, -5, and -1, -7. And then connect those. All right, so now we're ready for number 2. Again, we're going to make a new XY table, identify H, S, R, and V. The H, I don't have anything in parentheses with X, so that's not going to change. I do have a stretch or a shrink because I have 1/2 by out front, so this is yes by 1/2. There's no negative, so there's no reflection. There is a +3 at the end, so up 3. So now, since there was no h, all of my x's stay the same. These were the original x's we started out with. So we were at -4. Let's see. -2, -1, 0, and 1. So now we want to take all of our original y values, multiply by s, and then add the 3. So we're going to have 1/2 y plus 3. So our very first y value that we started out with, sorry, the very first y value that we started out with was the 2. So we're going to do 1/2 times 2 plus 3. So 1/2 times 2 is 1. 1 plus 3, 4. Our next y value that we started out with was 4. So 1/2 times 4 plus 3. So half of 4 is 2. 2 plus 3, 5. The next y value that we started out with was 3. So 1/2 times 3 plus 3. So I've got 3/2 plus 3. I'm going to go ahead and make that 6/2. So then I have 9/2. Or that would be 4.5. The next y value that we started out with was 5. So 1/2 times 5 plus 3. So I have 5/2 plus 6/2. So I get 11/2, which is 5.5. And then the last y value that we started out with was 7. So we would have 1/2 times 7 plus 6/2. So 7/2 plus 6. So we're at 13/2, which is 6.5. So these are the points that we're going to now plot. So -4 up 4. So over -4. Over -4 up 4 puts us right here. Over -2 up 5. Over -1 up 4.5. Over 0 up 5.5. Right there. Over 1 and up 6.5. Over 1 up 6.5. Right there. So then when I draw this graph, I'm looking at that. That was what we finished on Friday. And then I want to go ahead and walk you through what we will be doing on Monday. So Monday, they're going to give us all the graphs, so the second part of section 1.2, and all we have to do is identify the transformations from a graph and then write the equations. So this first example, they tell me the graph of f is f of x equals x squared, and that is what is in blue on this graph right here. So it wants us to write the equations for the graph of g. So g is our red graph, so I'll switch to red pen so we can see what we're doing. Okay, so g, I take my point here at 0, 0, where I started out with, and I see that it went to the right. It went to the right 4, and then it went up. First we'll do HSRV. So the H, it goes right 4. And then instead of starting at 0, 0, now we can look at vertical shift. It went up 5 units. So up 5. I know that there's no reflection because it's not opening down. I can check for a stretch. So if I take the original point, let's see, over 2 up 4, okay, so that would now be over 6 up 6. And so I have not changed anything. So there's no stretch. Okay, so my new equation is going to be f of x equals, in parentheses, because that goes right 4, and that's always opposite, so it would say x minus 4 quantity squared, and then it went up 5, so plus 5. So now we want to go to the graph H, which is the dotted line. Again, I'm looking at HSRV. I again notice that it has shifted to the right. So it went right, starting at 0, 0, it went right 4. It did not go up or down any, so I see there's no vertical shift. I see there's no reflection because it's not opening down. So then again, look for a stretch. Okay? So this point right here, if I simply move it over 4, 1, 2, 3, 4 is still on that graph, so I know there's no stretch or shrink. So this equation of the graph H would be f of x equals, all that I had was a shift right 4, and again that goes in opposite, x minus 4 quantity squared. So now the last page of notes. We start out with everyone's favorite word problem. We're going to write an equation from the graph. It tells us a scenic train ride Makes trips on an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as a function of time? What is its domain? We see that it is a V shape, so I know it's going to be absolute value. We can check for H, S, R, and V. Remember that we know it would have started at 0, 0. We have a reflection, yes, because it's opening down. It's not starting at 0, 0 anymore. It got shifted over. My new vertex is at 15 for the x value. So I see that it went right 15. Also for vertical shift, it's not at 0, 0. I see that it went up the y value 15. So up 15. I can see that down 1 over 1, down 1 over 1, those points are going to be on there, so there was no stretch or shrink. So the new function of this graph, f of x, equals negative on the outside because of the reflection, absolute value, it went right 15, so x minus 15, and then up 15 plus 15. So that is the equation of this graph. So now we want to find out what it is the domain. Remember that domain are our x values. We start from the smallest x value, so we start at 0. It's included, so bracket 0, comma, the largest x value out here is 30. It is also included, so bracket 30. Just to review, let's go ahead and find the range as well. Remember, range are y values. The smallest y value on the graph is 0, included brackets. The biggest y value is up at 15, also included brackets. Okay. So now we're going to write the equation of the graphs. We're going to look at our parent function. Okay. So in blue is f of x equals, I see that it starts at 0, 0. So I know it doesn't have any kind of shifting left or right. It's a U shape, so I know it's an x squared. If I check my original points, over 1, up 1, over 2, up 4, that's what's on the graph. So in blue, f of x equals x squared. So now we want the green. We want to see what happened to it. I noticed, okay, H, S, R, and V. I noticed that it's opening down, so I know I have a reflection. I noticed that it did not move on the y-axis, so there's no vertical shift. It shifted on the x-axis, and it shifted left. It's like 3, so it's going left 3. And then I can check for a stretch or a shrink. So if I took my point 1, 1, so 1, 1, I know it's reflected, so it would have been now 1, negative 1. And I go over 1, 2, 3. It is on that point, so there is no stretch or shrink. So this equation is going to be f of x equals negative on the outside, parentheses, x, it went left 3, so inside goes plus 3, quantity squared. Okay, so now we're going to look at the next example. We will look at the blue one. Again, we see that it is an absolute value, so I know that, let me see if I can change that. Okay. So the blue absolute value, let's check our x, y. I've got a 0, 0, 1, 1, over 2, up 2, so 1, 1, 2, 2, negative 1, negative 1, sorry, negative 1, positive 1, negative 2, positive 2. So the blue here, what is f of x equals the absolute value of x, just my parent function. So now we're going to look at the green dotted. I'm going to do H, S, R, and V. I noticed that it did not shift any left or right, so there was no horizontal shifting. I noticed vertical right off the bat that it went up, and it looks like it is up at 3, so it went up 3. It is opening up, so there is no reflection. I do notice that it is wider than the original one, so I need to check what the S value is, what the stretch is. I need to find that A value. So I'm going to go ahead and write my ordered pairs for my green. Okay? So again, I'm going to look at, I see 0 is now 3. If I go over 2, up 4, so 2, 4 is on my green graph. Let's see, 4, 6, 6 is on my green graph. I go the negative direction, negative 2, 4, and so then negative 6, 6 is also on my graph. So now I need to find out what that A value is. Remember that we've learned the basic transformation function looks like f of x equals A, absolute value x minus h plus k. The h was here, so there's none. We don't have to worry about that, so I know it's going to be just an absolute value of x. The k comes from my vertical, so I know it's going to be a plus 3. So now I need to find out what is this a value. I can do that by picking one of these points. I'm just going to pick the point 2, 4. And I'm going to plug in here, okay, because this is equal to f of x. Remember, f of x is the same thing as y. So I had 4 for my y value equals a. My x value was 2, and then plus 3. This I want to solve. I can subtract 3 from both sides. So now I have 1 equals a times the absolute value of 2. To get a by itself, I simply need to divide by 2. So I see that my a is 1/2. So it had a stretch value of 1/2. So to write my equation, it is f of x equals the 1/2, that a we just found, times the absolute value of x. We didn't have any left or right movement, so just absolute value of x. It shifted up 3, so plus 3. So that gets you the rest of Friday's notes and then Monday's notes. Let me know if you have any questions.